recognize this. What is that an equation for? Actually, it's I think it'll work out. So what it is, it's the equation for an ellipse. I don't know exactly what the ellipse looks like, but if you put it in standard form, you'd find it's an ellipse with center somewhere other than the origin. I'm pretty sure, yeah. So what I thought I'd do is show you how you find the slope of the tangent line for this ellipse, both explicitly and implicitly. So implicit, let's do it implicit. That's what we're learning here. So if you take the derivative with respect to x of this expression, so you take the derivative with respect to x of every term. So those are all the terms. All I did was put ddx in front of each one. So the ones that involve x, I just use the normal rules. The ones that involve y, I do the same thing, but I put a y prime on the end of it. So I get that when I take the derivative. So the derivative of x squared is 2x. The derivative of y squared is 2y, y prime. The derivative of negative 4x is negative 4. The derivative of 6y is 6 times y prime. And the derivative of a constant is 0. So then what I would do is I would group the terms involving y prime on one side. So you'd have 2y, y prime, plus 6y prime is equal to 4 minus 2x. So I moved this to the other side, and if they were positive, they became negative. If they were negative, they were positive, and I put the positive term first. Then you factor out the y prime, so it leaves you with 2y plus 6 here. And then you divide both sides by the term in the parentheses, and you get 4 minus 2x divided by 2y plus 6. So that's your derivative. And the slope is going to be 0 when the numerator is 0. And the slope will be undefined when the denominator is 0. So you probably could figure out where the vertices are, I think. At least you know where the slope is 0. And then once you know, you could, anyway. So that's how you do it implicitly. Explicitly, you've got to solve the equation explicitly for y. So you have to do that, you'd have to put it in standard form. So I'm just going to show you, we'll learn how to do this in second semester. You may have seen this before. So it's just, what you do is you group the x and y terms together like this, and you put the constant on the other side. So all I've done is rearranged the terms, and then you complete the square for each one of these. So you would take negative 4 divided by 2, and you'd square it. So that's negative 2 squared, which is 4. So you add 4 here, and you have to add 4 on the other side to balance that out. So I'm adding the 4 so I can make this into a complete square, and I'm adding 4 here to balance the 4 that I added on the left-hand side. And then you do the same thing over here. You take 6 divided by 2, this number, divided by 2 squared, which is 9. 3 divided by 2 is 6 divided by 2 is 3. 3 squared is 9. So you'd add 9 here and you'd add 9 there. So that allows you then to make this x minus 2 squared, and this is y plus 3 squared. And if you add these numbers together, you end up with 4 because the 9's cancel out. And actually, it's a circle, not an ellipse, because it's a circle with the center offset. So the center would be at x equals 2, y equals -3. So I still haven't solved for it explicitly. So to do that, I would put the y terms on the left-hand side. So I'd have 4 minus x minus 2 squared. So that goes over to the right-hand side, becomes negative. Then you take the square root. So you'd have y plus 3 equals plus or minus the square root of 4 minus x minus 2 squared. And then you subtract 3 from both sides. And you get y is equal to -3 plus or minus the square root of 4 minus x minus 2 squared. Okay, so that's, don't worry about if you don't get that completely at this point. We'll practice it more next semester. But so by putting it in standard form, you know that it's a circle because it's got the same, if you divide by 4, you'd end up with the same denominator. And, you know, just normal rules for algebra or for pre-calculus in terms of finding the center. Okay, I'll make sure I did all that right before I... Okay, so now we have to find dy dx, we have to take the derivative of this with respect to x. So let's do that. We'll use the chain rule. So let me add a page. So let's see. This first part's going to go to 0. And depending upon whether you take the positive square root or the negative square root, you're going to get a slightly different result. I'm going to take the positive square root, which would be the top part of the circle. So let's see, how do I want to do this? I would rewrite it as a fractional exponent. Now, to save myself having to use the chain rule twice, I'm going to go ahead and multiply out in the inside and just simplify it before I do it. So I'll have 4 minus quantity x squared minus 4x plus 4. So just use FOIL on this thing. You see the 4's cancel out. So I'll get -3 plus, see, this 4 cancels out with that 4 because this is plus 4 and that's minus 4. So what I end up with is, I'll end up with 4x minus x squared. So again, I changed the order so that the positive term is first. Okay, so now what I can do is I can let f of u equal u to the 1/2 power and u of x equal 4x minus x squared. I'm not going to worry about that part because I know the derivative of that is 0. So I'm just worried about the second part. So you take the derivative, f prime of u is 1/2 u to the minus 1/2 power. And u prime of x is going to be 4 minus 2x. And then the chain rule says that f prime of x is going to, which is this part right here, is going to be 1/2 u to the minus 1/2 times 4 minus 2x. And if I substitute u back in and just work it out, you'll have 1/2 square root of 4 minus x squared times 4 minus 2x. So I've moved that to the denominator to make it a positive 1/2, and then I've rewritten it as a square root, and you can see the 2's cancel out here, so I'll have 2 minus x over the square root of 4x minus x squared. So that's y prime in this case. So again, what I did is I explicitly solved for y. When I take the derivative of this term goes to 0, so I just worried about this second term. I rewrote as a fractional exponent. I multiplied this out so I didn't have to use the chain rule twice. And then I took the derivative, and then I did all of my stuff there. And you can see the result doesn't look the same if we compare the two. So here y prime is 4 minus 2x over 2y minus 2y plus 6. But you can actually, I'm not going to do it, but you can prove that that they are the same thing. If you take y and you plug it in here, this y into there, and simplify it, you should end up with something like that. Okay. Which was the easier one? In this case, implicit differentiation to me was easier because I didn't have to solve the equation implicit. I didn't have to solve the equation explicitly. I didn't have to use the chain rule. So, this is a demonstration of where implicit differentiation would be a lot easier than having to solve it explicitly. Okay, so that's another example. And then the final thing is find the equation, the tangent line for the cruciform at point -4, 2 times the square root of 3. So let's actually plot this thing out. Okay. So it cruciform sounds like it's going to be a cross of some kind. So let's see if that's actually true or not. So we're going to make a two-dimensional plot, and we're going to put it implicitly in there, and it's x squared y squared minus 9x squared. Okay, so x squared y squared plus minus 9x squared minus 9x squared minus 4y squared equals 0. Okay, so I think that's right. Let's plot it, and it didn't do anything. Okay. Let's zoom out a little bit. Page down. Okay. Equation. Implicit. Let's look at the equation again. X squared y squared. X squared y squared minus 9x squared. 9x squared minus 4y squared equals 0. Looks right. Oh, there it is. Okay. I just hadn't zoomed out enough. So that's what it looks like. And you can see that for every value of x, there's two values of y, so it's not a function. What they're asking for is to find the value of the equation of the tangent line at -4, comma 2 times the square root of 3. So let's see where that is. -4, 2 times the square root of 3. So it's right there. So just guessing, it looks like it would be, it's going to be positive slope. It's probably less than 1. The scale's a little, so let's see what we get. Okay. Well, why don't you try that one? Go ahead and take the derivative of that thing. So let's do the derivative first. So remember, the first one is a product. So the product rule says you take the first term times the derivative of the second plus the second term times the derivative of the first. So my calculation, you should have to do 2 implicit differentiations, both involving y squared. So you're gonna want to solve for y prime. So just like we did over here, you can do the implicit differentiation, which actually we have a term that looks very similar to what we have. Group the terms of y prime on one side, factor out the y prime, and then solve for it. So you've got the procedure there on your left-hand side to follow if you're forgetting what you're doing. So there's the derivative. Anybody have any questions on what I did there? So first term times derivative of the second, there's implicit differentiation. Derivative of the first term times the second, no implicit differentiation. No implicit. Okay, so there you go. Hopefully you got that. So we factored, put the y prime stuff on one side. We factored out the y prime, divided both sides by that. So that's the derivative. So now what you're going to do is you're going to find y prime. So you'll find y prime at x equals -4, and then you will, so that'll be your slope, and you have x and y, you have -4, 2 times the square root of 3, so that's x1, y1. So then stick it into y minus y1 is equal to m times x minus x1, and then solve for y. So go ahead and do that. So you'll use the equation for the derivative, and you've got to plug both x and y in here. So not just x. So find y prime at x equals -4, y equals 2 times the square root of 3. So that's different than what we've had to do in the past. And if you want to do it, I'm not sure how it simplifies, but just use your calculator and come up with a decimal answer for the slope. Won't make you have to simplify. And hopefully you get a negative number, because that's what it looked like it was supposed to be, negative slope. And I'm going to go ahead and hand out the back side of the page that we didn't get to yesterday. Okay, just turn it in after class. So I'll let you get by with doing a decimal point. I'm going to stick it in and see what I get if I simplify it, just as a little exercise here. Actually, it might not be too bad because you square some stuff here. 2 times. Let's see. Actually, it's a positive slope, isn't it? Yeah, it should be a positive slope right there. So, because I'm getting a positive number, so what is that? So that's 12 times 8 is 96. 96 minus 72 is 24. 24 divided by 64 minus 16 is 48. 48 square root of 3, which is, that's actually 1 over 2 times the square root of 3, which if you multiply by the square root of 3, you'll get square root of 3 over 6. Is that right? Did I do that right? This wasn't as bad as I thought. So we'll see whether you got the same answer. So the square root of 3 divided by 6 is 0.289. Is that what you got? Yeah, 0.289. So let me just explain what I did here for you guys who just plugged it in your calculator. So here you plug the numbers in. So 8 times 4 is 72. It's negative 72. What I did then was I took negative 2 times negative 4, which is positive 8. And when you square this, this squares, so you get 4, and the square root of 3 squared is 3. And if you take 8 times 4 times 3, that's 8 times 12, which which is 96. Is that right? Yeah, 96 minus 72 is 24. And then you have, in the denominator, you have 4 times 2 times 4 squared, which is 2 times 16, which is, wait a second. Oh, another 2. Yeah, so you get 2 times 2, which is 4 times 16, which is 64, times the square root of 3, minus 8 times 2, which is 16. So you get 16 square root of 3. So 64 minus 16 is 48. So you end up with 24 over 48, which simplifies to 1/2. And then I multiplied the numerator and the denominator by the square root of 3. So I get the square root of 3 over 2 times 3, which is that, and that gave me the answer. Okay. So then the second part, you plug in your values of x and y and your slope. So I've got the square root of 3 over 6 here, times x minus x1, which is -4. So what do we get? We get y minus 2 square root of 3 is equal to the square root of 3 over 6 times x, and then we get 4. So it's plus 4 divided by 6 is 2/3, so you get 2 square root of 3 over 3. 4/6 is 2/3. And then if you add this to both sides, you'll get, so that's 2 is 6/3. 6/3 plus 2/3 is 8/3. So plus 8 square root of 3 over 3. I think that's right. And if we actually plot that line, hopefully on this graph it'll work out. So I'm going to take, I think I can plot more than one function. So it's an explicit, it's a linear function, and it's square root of 3 divided by 6 times x plus 8 times the square root of 3 divided by 3. There it is. How about that? So we did it. I always get excited about that, even after 9 years, when it actually works out. You do all your math right, you check it out on a graph, and it works. So you can see, at x equals -4, y equals, they told us what it was. And that is that line is tangent to the curve at that particular point. Does anybody have any questions about any of the steps that we went through? Okay, so let's look at the handout. So the first one, the question may be, do I have to use the quotient rule, or can I do something else? What else could I do maybe to make this easier, to not use the quotient rule? If I multiplied every term by x times y, that would eliminate x and y from the denominator. So let's think about that. Is there any problem in doing that? So let me add a page. So if I took this equation and I multiplied by xy, in the first term you'd have x times xy divided by y. The second one you'd have y times xy divided by x, and then you'd have 2 times xy. So I can cancel out the y, so I end up with x squared here. Cancel out the x's, I end up with y squared there, and I'd have 2xy. So it seems like the math is, that's a lot easier, right? We've just done some things like that. I don't think it's going to hurt the derivative calculation, but what's the difference between this equation and the original equation? if I multiplied everything by the same number, you think it should be the same. So are there any values of x or y where this is undefined? No. Are there any values of x and y where the top equation is undefined? Yes. So when x equals 0 and y, if you let x equal 0, then the function goes to, the value has to go to infinity. I guess unless it's y equals 0. So what I'm going to ask is, you do it this way. I'm going to do it the other way. Let's see what kind of answers we get. I'll use the quotient rule. You guys can use the just use the product rule on the second term, and then we'll see if there's any difference in the results. Because you guys can do this one. You could do this one too, but so the quotient rule. What is the quotient rule? It's double check my answer here. So what'd you guys get? An answer? Did you get it? You got 1? So it all canceled out into be 1? Okay, let's just double check that. So you get 2x plus 2y y prime is equal to 2x y prime plus 2 y. Is that right? So far, so good. 2y y prime, then use the product rule. So you get 2x times the derivative of that, which is y prime. And then you get 2y times the derivative of that, which is 1. Okay, so then you get 2y y prime minus 2x y prime is equal to 2y minus 2x. And then you factor out y prime, so you get 2y minus 2x is equal to 2y minus 2x, or y prime is equal to 2y minus 2x over 2y minus 2x, which is 1. Or, is that right? Yeah, okay. So that's how we got 1. And then I got this thing over here on the other side. And you're like, they should be the same, or something's funny. What's going on here? When would this always be 1? Why would this always be 1? Or could it always be 1? I guess if the numerator always equal the denominator, right? So if the solution, if y versus x is just a straight line where y equals x, then actually you end up with an indeterminate result. And likewise here, this is 1, but it could be indeterminate if x equals y is what the function looks like. So let's actually plot this thing out. Let's see what it looks like. So if we plot, so let me clear this new. So I'm going to do an implicit equation, and it's going to be x divided by y plus y divided by x equals 2. Okay, so let's plot this and see what it looks like. Nothing happened. Okay, so when that usually happens, we zoom out and see if we can see if it's just I'm not seeing it. So I'm going to zoom out a little bit here. So let's try it again. So y divided by x plus x divided by y equals 2. Okay. I don't know what that means. Is that not even a function? I got this out of the book. I got it out of the book, so that's interesting. We may have to come back and look at that. I think I vaguely remember something about that last year. Now that's coming back to me. You know, you can't move on. So yeah, you did the mechanics correctly. Why did it end up doing what we had there? I don't know. Okay, let's look at the next one. By the way, there's your homework assignment. Did I already assign that? I can't remember. So the next problem is, I think this one actually does exist. So you have xy plus y squared equals 6. So go ahead and find y prime equals something, and then what you'll do is you'll plug in. So you'll find y prime at x equals 1, y equals 2, and then that is your slope. And then you have x1, y1 is equal to 1, 2. Stick it in the point slope form of the linear equation and solve for it in the slope intercept form. Okay, so I'll let you do that one. It's very similar to the one we just did, right? While you're doing that, I'm going to plot it to see if it actually does have an equation. some kind of slope here we can look at. So it was xy plus y squared equals 6. Let's see what that looks like. Yeah, so it does actually have a curve. And what we're looking at is the point 1, 2, so it's right here. So it looks like the slope should be negative, maybe negative a half. That's my guess as approximation. So we'll see here. So go ahead and work through that. So again, follow the steps. You only have one. Well, you have to use the product rule on that product. So okay, I've given you enough head start here. So what do we have? X, y prime plus y plus 2. So there you go. There's your answer. So we use the product rule on this. So you take the first term times the derivative of the second. Because the second part is y, the derivative of y is 1, but you multiply by y prime, so you get x times y prime. Then you have the derivative of the first part, which is 1, times the second part, which is y. The derivative of y squared is 2y times y prime. Derivative of 6 is 0. So you move this to the other side. So all the terms involving y prime are on the left-hand side. Factor out y prime. Divide by this thing you factored. And that's your equation for the slope of the tangent line at any point on the curve. And then you plug in y equals 2, x equals 1 into that to find the value of the slope, or the derivative. So that's the slope of the tangent line. Then you plug that into the point slope form of the linear equation. Put it in so we get negative 2/5 x, and we get negative 2/5 times negative 1, which is positive 2/5. And then we add 2 to both sides, which is 10/5. So 10/5 plus 2/5 is 12/5. And I plotted that, and you can see that it worked. So we're all happy again. Okay, so what we're going to do starting tomorrow is we're going to go to the next section, which is the last section in this chapter. And this is the one that people have the most trouble with, so we're going to spend a reasonable amount of time. It's what happens when you take some geometric relationship, which x and y are related, and you take the derivative with respect to time. So it's a lot of implicit differentiation. It's also word problems, so you have to figure out what the geometric relationships are based upon the statement. So we'll probably spend at least 3 days or more on the section, just because it is something people have trouble with. So, but we'll finish for today because we're at a nice stopping point.